Question 3. This question is about elements in period 3 and their compounds. When a piece of sodium is added to 200 centimeters cubed of water in a large beaker, a vigorous reaction occurs. The temperature of the water increases by 25 degrees Celsius. Give an equation including state symbols for the presence of sodium with water. So it's going to be 2Na solid plus 2H2O liquid arrow 2NaOH aqueous plus H2 gas. 2Na solid plus 2H2O liquid form 2NaOH aqueous plus H2 gas. 9 times out of 10, if you see a question about period 3 elements and their compounds, it's usually going to be equations. So if you haven't learned the equations, because period 3 elements and their compounds, like 2 pages in a textbook, CGP revision guide, of just equations, and also a couple of other things as well, about structure and bonding as well. But yeah, a lot of the time, they just like use equations that are in the textbook. Obviously, sometimes they do use equations that aren't from the textbook, and then you have to use your knowledge of the previous equations to, find out what to do. But 9 times out of 10, the equations that they use are previous equations from the textbook. So if you just learn them, you'll know them off by half, and you get the easy marks. And then it says, suggest why it is dangerous to react to similar piece of sodium with 10 centimeters cubed of water in boiling tube. Well, the temperature will increase more. Let's just write down. Temperature I really want to type this out. Okay, there we go. So temperature will increase more. And obviously, if your temperature is increasing even more, it's going to become more dangerous to use in a boiling tube, because the boiling tube or the hydrogen is flammable, the glass could shatter, and the mixture could explode. And then it says give an equation reaction of phosphorus oxide with water. So phosphorus oxide P4O10 plus 6H2O arrow 4H3PO4. And again, this equation is in the textbook. I can check right now. That's what I'll do. Just check right now if it is in the textbook or not. Period 3 elements and the oxides. It is in the textbook, yeah. It doesn't ask for state symbols, so we don't give it. You don't need to give it. And then suggest a pH for the solution formed. Well, let's just say +1. -1 to +1 should be fine. -1 to +1. And then it says, explain in terms of crystal structure and bonding why silicon has a higher multiple than phosphorus oxide. Classic question. 4 marks. Well, we should know that silicon or silicon dioxide, SiO2, has a macromolecular, hence has a giant covalent structure, therefore has strong covalent bonds between atoms, which need a lot of energy to overcome. It's high. Whereas phosphorus oxide P4O10 has weak. Actually, no, it doesn't. It's a simple covalent. It's a molecular. Is molecular. Hence has weak van der Waals forces between molecules, which need little energy to overcome. Hence break easily. Classic question. Structure and bonding. Well, silicon dioxide is macromolecular, aka giant covalent structure. Therefore, strong covalent bonds between atoms which need a lot of energy to overcome. Whereas P4O10 phosphorus oxide is molecular, a simple covalent molecule, hence has weak van der Waals forces between molecules which need little energy to overcome, hence break easily. And then you could say, if you wanted to, therefore silicon I5 oxide has a higher multiplier than phosphorus 5 oxide, or silicon 4 oxide, I think that's called. But that's not necessary. Then it says element in period 3 forms an oxide insoluble in water. Oxide reacts with sulfuric acid and aqueous potassium hydroxide. Give the formula of this for this hydroxide. The oxide reacts with sulfuric acid and with aqueous potassium hydroxide. Okay. So sulfuric acid is an acid. Aqueous potassium hydroxide is a base. So what we call something that can react with acids and bases is called amphoteric. And the main example of the amphoteric molecule that you should have studied is Al2O3, aluminium oxide. But however, they worded it really weirdly. Like, they're not telling you, they're not trying to tell you, they're just trying to trick you out. But if you read the question properly, if it reacts with sulfuric acid and with a base, aqueous potassium hydroxide, it's got to be amphoteric. And what's the key oxide that's amphoteric? Aluminium oxide. I'm pretty sure that's the only one you study for aluminium oxide. And then given the equation for the reaction of oxide with sulfuric acid, well, Al2O3 plus 3H2SO4 to form Al2SO4 3 plus 3H2O. Al2O3 plus 3H2SO4 arrow Al2SO4 plus 3H2O. Give the formula of a hydroxide of an element in period 3 used in medicine. Well, what we've got magnesium hydroxide, calcium sulfate, and we have, what is it called? Barium sulfate, magnesium hydroxide, barium sulfate. The formula of a hydroxide used in medicine is going to be magnesium hydroxide. So MgOH squared. Magnesium hydroxide is used to neutralize stomach acid as an anticide, pretty sure. Yeah, something to do with acid in your stomach. And then identify the element in period 3 from sodium to chlorine that has the largest atomic radius. This is going to be Na, sodium. And that's the end of question 3. Overall, this question 3, is a pretty nice, how many marks is it? 12 marks. Like, this equation I'm pretty sure is in textbook, learn it off by heart, so you should have got that mark. This one suggests why it's dangerous. Yeah, it's a bit of AO2, so you do need to like think about it, but if you think about it, temperature can increase more, mixture can explode or shatter. the what's it called, the boiling tube shutter. Given the equation for reaction of phosphorus, 5 oxide water, P4O10 plus 6H2O 4H3PO4, that's in textbook, suggests a pH for the solution form, -1 to +1. And then this one's a really nice question. Silicon dioxide is micromolecular and has a giant covalent structure, therefore a strong covalent bond between molecules between atoms which need a lot of energy to overcome, whereas P4O10 is molecular, or we could say simple covalent molecule. Yeah, let's just write that down. Or simple covalent molecule, hence has weak van der Waals force between molecules which need little energy to overcome, hence break easily. Al2O3, aluminium oxide, Al2O3 plus 3H2SO4, Al2 bracket SO4 3 plus 3H2O. Magnesium hydroxide is in the formula of a hydroxide used in medicine, and then sodium is the element with the largest atomic radius.